8.5, strategies for integration. So this section, if you will, is just going to have a hodgepodge of all the different techniques all put together, and you kind of have to sift through to figure out which one it is that you're going to need. So always remember to simplify an integrand. That's taking out scalar factors, foiling, things of that nature. Look for an obvious substitution. That would be look for your x raised to some power, could be in your denominator, could be inside of a square root, and then an x to 1 degree smaller outside the function that you can multiply to the dx. Classify the integrand according to its type, for example, trig functions, powers of your sines and cosines, secants and tangents, cotangents and cosecants. Rational functions, doing your partial fraction decomposition, integration by parts, any radicals with positive or negative x squareds and a squareds in them. And then sometimes you just got to be creative. U sub or a combination of the methods, or convert to sines and cosines, things of that nature. All right, first example, example 1. We have sine of x plus secant of x all over tangent x as the function that we want to integrate. Right now, what I don't like is that there's a sine function mixed in with my secant and tangent. So I just happened to mention it. We're going to change everything to sines and cosines. So time to review our trig here. I'm going to rewrite this because there's one trig function in the denominator. I'm going to write this as 2 fractions. We can separate it as long as there's one factor in the denominator. And then we'll simplify each one of these fractions. So I'm going to look at sine of x over 1. Tangent of x in the denominator, or 1 over tangent of x, is cotangent of x, which is cosine x over sine of x. Or if you want to think of it as, okay, tangent is sine over cosine, but I'm dividing by it, I have to multiply it by its reciprocal. Secant of x is 1 over cosine of x, and the same thing here with tangent of x. We'll have to put the cosine x on the top, sine of x on the bottom, just like we did here. And now we can do some canceling. Cancel the sine of x, cancel our cosines of x. And that's going to leave me with cosine of x plus 1 over sine of x, which we'll call cosecant of x. And so if I integrate cosine of x, that's going to be sine of x. And if I integrate cosecant of x, check that out on your table. I believe that's the natural log of cosecant of x minus cotangent of x, all inside your absolute value bars. Then your plus c. Example 2. Here you have x to the 4th plus 2 on the bottom, x to the 1st on the top. So I was thinking of a u sub, but I really would like to see x cubed here. I don't have that. So the next thing I'm going to do is I'm going to change this x to the 4th. I'm going to change that to an x squared squared. And then I'm going to take the 2 and I'm going to make that an a squared. So I'm thinking that I'm going to try to use my x squared plus a squared on the bottom and use my, I think it's my inverse tangent is what I'm looking for. So this is going to be my integral formula that I would like to use. So I'm going to let u be x squared, and then du is 2x dx. So there's my x times my dx. We'll just have to take the 2 and divide it over to the du when we substitute it in. My 2, that's going to be my a squared, and then so a is the square root of 2. So now I'm going to have 1/2 times the integral of x dx, that's my du, with my division of 2, went over with du, so I factored it to the front, u squared plus a squared. And I'm just going to write this in here. We're going to integrate with this formula, so that's going to be 1 over a times the inverse tangent of u over a plus c. Keep the 1/2 multiplied out front. And now let's bring the a in. So the square root of 2 here and the square root of 2 here. Put in x squared for u. And then there's my final answer. Example 3, we integrate from 0 to 4. We have x minus 1 over x squared minus 4x minus 5. This is a proper fraction. Top degree is smaller. You could try to do a u sub, but you're going to have 2x minus 4, and we have x minus 1, so that's not going to work out. So I'm going to go to partial fraction decomposition. Factor my bottom. I'm going to get x minus 5 and an x plus 1. And we'll put a over x minus 5 plus capital B over x plus 1. And then from here, we'll go ahead and multiply the least common denominator, which means x minus 1 is going to equal a times the x plus 1. And the x minus 5 gets multiplied to my b. Again, remember, we're multiplying these two binomials to both sides. So cancels this out. Cancels the x minus 5, leaving me an x plus 1 times my capital A. My x plus 1 cancels, leaving x minus 5 being multiplied to my b. So here, since there's only one factor for the capital A and capital B, I'm going to let x equal 5. So that'll cancel this binomial out to a 0. And so 5 minus 1 is 4. 5 plus 1 is 6. We can solve for a, divide over the 6, we get 4/6, which becomes 2/3. And then I'm going to do the same for this binomial. I'm going to let x equal a negative 1. So negative 1 minus 1 is negative 2. Negative 1 plus 1 is 0. That's gone. Negative 1 minus 5 is negative 6. Divide that over. B is equal to 1/3. So we'll change this to the integral of 0 to 4, 2/3 over x minus 5 plus 1/3 over x plus 1. And now we can have our natural log rule. So we're going to get 2/3 times the natural log of x minus 5 plus 1/3 times the natural log of the absolute value of x plus 1. Don't forget your absolute value bars. And we're going to evaluate it from 0 to 4. So let's plug in a 4. So they're going to get natural log of 4 minus 5, which is negative 1. But don't worry, we're just going to take the absolute value of that, which makes it a positive 1. And 4 plus 1 is a 5. So we're all good. You can change this to a positive 1 if you want. 6 of one, half dozen of the other. Minus, now we put in the 0. 0 minus 5, that's the absolute value of negative 5, which will become positive 5. 0 plus 1 is 1, but I just realized, hey, natural logs of 1, or log of anything with a 1 in it, those are 0. This is 0, that's a 0, so 0 times a third is gone. 2/3 times a 0 is gone, so we have 1/3 times the natural log of the absolute value of 5, minus 2/3 times the natural log of absolute value of 5. We can combine that together. 1/3 minus 2/3 is a negative 1/3 times the natural log of 5. Example 4, we have x over x to the 4th plus x squared plus 1. So again, I'm kind of thinking, let's do that x squared for u, just like we did back in example 2. So if I substitute that in, we'll have x squared squared plus x squared to the 1st plus 1. So what I need to do is say u is going to be my x squared, du is going to be 2x dx, and I'm going to again try to get to that tangent inverse concept here. So if I factor this, or excuse me, put in my u's, I have 1 over u squared plus u plus 1. My x dx, and again, divide over the 2 to my du, so that's factoring out the 1/2. Again, what I'm going to do is complete the square of the bottom, so I can use this concept right here with my inverse tangent rule. So take u squared plus u plus a blank plus 1 minus a blank. So this is going to be my a squared, hopefully. So again, half of the 1 on the middle term is going to be a positive 1/2 squared, which will give me 1/4. This trinomial here is going to become u plus a half all that squared. 1 minus 3/4 is going to be 3/4. But we're going to turn that 3/4 is going to be my a squared. So take the square root of that. I'm going to get the square root of 3 over 2. That's going to be my a value. So if we rewrite this as now du over u plus 1/2 squared plus, all right, square root of 3 over 2 squared. This is my a. This is my x, if you will. So 1/2 times 1 over a, square root of 3 over 2 times the inverse tangent of u plus 1/2, that's my x, over the square root of 3 over 2 on the inside. And I think what I'm going to do is, because we're dividing by a fraction, let's multiply by the reciprocal. So move the 2 up to the top, radical 3 on the bottom. The 2's will cancel, leaving me 1 over the square root of 3. I'm going to bring down my x squared for my u, put that in, and I'm going to do the same thing here, multiply by the reciprocal of that to the binomial on the top, so 2 over the square root of 3 times x squared plus 1/2 plus c. Example 5, x to the third over the square root of 1 plus x squared dx. Definitely need to do a u sub here. Now this one's going to be a sneaky trick, so make sure you pay close attention here. My u is going to be the 1 plus x squared. My du will be 2x dx. Wait a minute. I only need x. I have x cubed. Don't panic. Take an x out of here like we did with the sines and cosines and tangents and secant powers. Put an x with the dx. So I have this x squared left. So now here's going to be the square root of u, and here's going to be my du, but again you have to divide the 2 over, so we'll have to bring in 1/2 and factor it in front of my integral here. But yeah, I know, we still got this x squared sitting here. Go back and look what u equals. U equals 1 plus x squared. Solve this for x squared. Just subtract the 1 over. And we'll put u minus 1 in for the whole numerator, x squared. And now we have everybody in terms of u. But this is kind of ugly, so I'm going to separate this as 2 fractions. U over the square root of u minus 1 over the square root of u. So again, this u on the bottom that's inside my square root is really u to the 1/2. So 1 u to the first divided by u to the 1/2, subtract your powers, that will be u to the 1/2, minus u to the negative 1/2, integrate using the power rule. This becomes, add a 1 to it, that's going to be 3/2, but dividing by 3/2 makes it multiply by 2/3. Add 1 makes this 1/2, divide by 1/2, multiply by the reciprocal of 2. And let's see, what can we do? Let's go ahead and multiply the 1/2 here and the 1/2 here, so that's going to be 2's cancel, 1/3. 1/2 times 2 is 1. And so we're going to combine this together. So this 1 that we ended up in front of u, I'm going to change to 3 over 3. So I can subtract or factor out, excuse me, I didn't want to subtract, I want to factor out the 1/3 and a u to the 1/2. So 1/3 u to the 1/2, if I divide u to the 1/2 from 3/2, that's just u to the 2/2, or 1, and then minus 3. Now we'll come back up here, grab our 1 plus x squared, put it back in for both of those u's. So 1/3 times the parentheses 1 plus x squared to the 1/2 power, or you can rewrite this as the square root of 1 plus x squared. And then 1 plus x squared minus 3, combine like terms, that's x squared minus 2. And there we have it integrated.